All right, so number 14, what are the possible solutions of this wonderful function right here? Well, it really, instead of just saying possible solutions, it should say possible rational solutions, because really you have no other way of figuring out what all the possible ones are. We only know our rational root theorem, and the rational root theorem is what we're going to use to try to find the possible solutions here. Remember from the rational root theorem that if I take all the factors, the integral factors, integral meaning integer factors, so I take all the integral factors of 24 in this case, and I'm going to divide it by all the integral factors of the leading coefficient, which this case is 1, it creates a P over Q list. The P over Q list are the possible rational numbers that could be the zeros of this function or the roots of this function. All right, so we're going to make our P list, and I'm going to have to go through and figure out all the numbers that when multiplied together will give me 24. That includes all of my plus or minus. So plus or minus 1 works, plus or minus 2, plus or minus 3, because 3 divides into 24, plus or minus 4. Let's see, how about 5? Nope. Plus or minus 6. All right, so now I'm rolling back the other way, because 6 times 4. So now what times 3 gives me 24? Okay, what times 2 gives me 24? And then lastly, what times 1 is going to give me 24, but 24. As we said before, the Q list, the Q comes from the integer right here. Well, that's a 1. How nice is this? Plus or minus 1. Now, considering that my P over Q list is nothing more than every single P value divided by every single Q value, well, every single one of these up here is just going to be divided by plus or minus 1. So my P over Q list, or all of my possible roots, are just going to be what my P list was. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and then lastly plus or minus 24. So that means that these are all numbers that could possibly be zeros of this function, that maybe this function crosses or touches the x-axis at any one of these numbers. Okay. Now, granted, I'm still dealing with 1, 2, 3, 4, 5, 6, 7, 8, and then I've got plus or minus, so that's 16 different values. But 16 is a lot better than dealing with infinitely many. So there are the possible rational solutions when dealing with number 14.